example number 1 may look a little bit familiar. This is actually a question we did on the previous lesson, coming up with inequality. So it should be fairly straightforward to go through that. But we say, because the supply of parts is limited, a toy manufacturing company can make no more than 40 racing cars and 60 SUVs every day. However, the company can make a total of 70 or more vehicles per day. Now, we're told that it costs $8 to make a racing car and $12 to make an SUV, and the company wants to know what combination of cars and SUVs will result in the minimum and maximum costs and what these costs will be. Okay, so the cost to make them is right here, and so that's going to become our target equation. So we're going to put that in there, or we're going to find that almost right away, our target equation. First things first though, we want to figure out what are x and y going to be. Okay, so let's define our variables. X is going to be the number of cars made, and y is going to be the number of SUVs made, okay, each day. To figure out if we want to maximize or minimize, okay, we're going to say that our total cost is equal to 8x plus 12y. That's going to be what our cost is, okay? 8 times x plus 12 times y is going to give us our total cost. $8 times the number of racing cars and $12 times the number of SUVs is going to give us our total cost as to how much we're spending each day. So that's going to be our target equation, and we're going to leave that off to the side just for the time being. Our domain, we know that x has to be whole numbers because it can't have part of a car, it can't have negatives. Range is going to be the same thing, whole numbers. It's supposed to be a W. Okay, and now we've got to come up with our inequalities which satisfy this situation. We know that x has maximum of 40. So x is less than or equal to 40. We know that y is a maximum of 60. So y is less than or equal to 60. And we know that combined they can make 70 or more. So 70 is going to be the lowest. So x plus y have to be greater than or equal to 70. And there's our inequalities, or what we might call parameters. Here's our restrictions here. Here's our domain and range. Here's our parameters that we're going through there. Now, what we can do is we can graph this out. And we have a graph right here. Or we can make this a little bit simpler and graph it out using Desmos. And so I'm going to bring in my laptop here, and we're going to try this out. Okay, so what we're going to do is we're going to type in is less than or equal to 40. Y is less than or equal to 60, and x plus y is greater than or equal to 70. I think I got all three of them in there, and now we're gonna have to zoom out. I think that's showing up okay. All right, there we go. Now what you'll notice, and I'm trying to kind of look at my screen, both screens here, is that we have an area right here. This triangle represents all three of those. Okay, so red is this area here. Okay, that represents less than 40. The blue, this bottom area here, represents less than 60. And then the green up here represents the area that's above 70 for those two combined. This area right here is the combination of all three of them. Now, if I click on these outside points, and I'm going to try to do, there we go. I notice that these 3 points make up that area. Okay, in this case, it's a triangle. Other cases, it might be something different, but in this case, it's a triangle. And so we have the points 1060, 4060, and 4030. Now I'm going to, just as you're kind of showing them there, I'm going to be writing those down on my page here. 1060, 4060, and 4030. Those are my 3 points, which are going to either maximize or minimize the cost on here. Okay, so whatever the corners of it are going to maximize and minimize. So I'm going to put this again away for right now. We're going to go back to the page. Seemed to work out not too bad. Okay, and so these are my points. Now again, I would graph this out if I was doing this as an assignment or on a test, but in my case right here, we graphed it out on Desmos. I'm going to call that good for right now. If you want to show this all your work on doc and then kind of pull the screenshots of your graphs off, you can do that. All right, these are my three minimum and maximum points, okay? But we don't know which is the minimum or maximum. Well, you might be able to see it, but which would not be a bad thing. But those are our mins and maxes. How we figure out the minimum and maximum costs is we plug these points back into this equation right here. So cost is equal to 8x plus 12y. And when I put this in here, cost is 8 times 10 plus 12 times 60. Okay, and now we're going to have to do a little bit of calculations, and a calculator is handy for that. 8 times 10 plus 12 times 60. This is going to give us a cost of $800 to manufacture 10 racing cars and 60 SUVs. If we do 40 and 60, we'll just switch out the colors here. Again, we're going to use the same formula. This is now our target formula. Our cost is equal to 8 times 40 plus 12 times 60. And so we're going to get a cost which is probably a bit bigger. 8 times 40 plus 12 times 60 is a little bit bigger. $1,040 is going to be that cost. And finally, the last one, okay, because we're going to do all three. Costs, again, same formula. And so this is 8 times 40 plus 12 times 30. And the cost here is 8 times 40 plus 12 times 30 is $680. Okay, so those are my three costs based on those min and max points. Now what we see here is that this one's going to give us a max, and this one right here is going to give us a min. So in our statement, we will say that the maximum cost for the company is $1,040 based on 40 racing cars and 60 SUVs made. The minimum cost is $680 based on 40 racing cars and 30 SUVs made. And that would be our final statement to represent that problem. Now, again, we can think of, this would be the minimum, this would be the maximum. Any one of those points inside of that triangle region that we had on the graph is going to represent a different cost, but they'll all be between. Okay, so no matter what combination we get that satisfies all of our parameters, okay, that we went through up here, whatever situation satisfies these, this will be the maximum and this will be the minimum. And that's how we come up with our optimization. So we say the maximum cost will be this, the minimum cost will be this. Okay. Now again, you might think of the fact that we didn't really maximize our revenue necessarily. We're just maximizing the cost or minimizing the cost of manufacturing. Revenue is a whole different ball of wax in this case.